Okay, so hello guys. So we were able to discuss motion in a vertical nga path, wherein we have discussed free fall. So for this time, we still have to consider a motion, especially when we have to consider the air. But this time we will have projectile motion. So you need as we go along the discussion, you have to describe the motion of a projectile by treating horizontal and vertical components of its position and velocity. You are also expected to solve for the position, velocity, or time when given initial velocity and the launch. So what is a projectile motion in general? A projectile is a particle moving near the Earth's surface under the influence of its weight only. So take note of the clue here. We have here weight only. That means the only force that is acting on a certain particle is directed downward only. Okay? Still the same, since because the weight is the only influence here in our given particle. So what will be considered here will be the force due to gravity. So our acceleration consideration here will be on the gravity. So in terms of the vertical and horizontal motion, so let us observe what will happen to the when we simultaneously drop yellow ball and we project a red ball. So this one we have to learn or to see the difference and the similarities of dropping using free fall and using projectile motion. So the red ball here will be projected horizontally and the yellow ball here will be dropped using the free fall motion. Okay, so we are going to see what will happen here. Okay, so simultaneously dropping a yellow ball and projecting a red ball horizontally. So take note of what was happening here. Despite a different action we have done, either it will be free fall or projecting horizontally, you could observe that they strike the ground at the same time. The question is, why do they strike the ground at the same time? Okay? Bisan gindagdag mo man siya or ginhaboy mo siya in a projectile motion, still, at the same time, they strike the ground. Once motion is begun, the downward weight is the only force in the ball. So, amo lang na ang nag-act sa aton nga ball. So ball projected horizontally and another dropped at the same time. So take note that a specific na given time, they have the same vertical distance nga cover or na travel. So ang aton nga projected horizontally kaya ang aton nga may ara motion nga free fall lang. Okay? Let us observe now the motion of each ball. So inspect sila isa-isa hunta. So vertical motion is the same for each ball. So take note, at a specific na given time, the same lang ilang nga distance ka na cover. Now, let us consider the displacement and their velocities. Okay? So we have the displacement nila. So at 1 second, so same lang ilang kaka-move. Ang difference lang naton sa aton nga projected horizontally will be movement niya halin sa initial in terms of the horizontal nga distance. But for the vertical distance, they travel the same. And take note, based diri sa aton nga representation, the horizontal velocity doesn't change. So Vx lang siya. So wala nag-change. So that means vertical velocity just like free fall lang Japan. So wala sang difference yung mga horizontal velocity, therefore it will act as free fall. Okay, so we have to consider, so nakita to naton we have a distance, ari nga distance halin diri pakadto sa sininga part or sa sininga point. So sa aton nga end point or sa aton nga terminal point. So amo nang kinahanglan man naton i-solve, isa sa kinahanglan naton i-solve. That will be your horizontal projection. So, tabalo kita that for any constant acceleration, based on the previous discussion, so we will have x is equals to VOT or VIT plus 1 half AT squared. So for the special case of horizontal projection, we will have to discuss this on later on. So we'll have horizontal displacement. So we will have sa horizontal displacement, wala kasang action sang acceleration kaya wala man siya nag-change. So that will be wala kasang gravity. So we will have VIT lang or VOXT lang. Okay, so this one para sa vertical displacement kung ano ang travel niya nga height, that will be 1 half g t squared lang. So this happens, discuss naman siya karon paano nagamo niya ang ating mga formulas. So for the velocity calculation for horizontal projection, we will have, so for any constant acceleration, so we know that this will be the formula. This one, ang muna kinahamba ko sa inyo that we have to be familiar of the different nga sari-sari ang mga formula for as long as we know the concept kung nga anaga mo ng formula. So despite lain pa na din ginagamit yung mga letter or representations, it will be the same. So VF is equals to VO. So sa iba natin ng mga calculation, VI na di siya, but still that represents an initial niya velocity. VF is equal to VI plus AT. So for the special case of projectile, so your horizontal velocity will be, kung horizontal lang, so take note nga may ara kita sang, since naka-angle siya ang mga movement. So that will be, that means may ara ka sang horizontal kag vertical component. So that means sa gamiton ta horizontal velocity is a horizontal component man, so we have x niya nga value. So for the vertical velocity, so, sa horizontal component, take note, wala kita ma-zero na because wala kita action of gravity. Wala kita gravity sa horizontal component. Kaya same lang ang horizontal value all throughout. For the vertical velocity, so we'll have VO plus GT. We will have the gravity consideration. Okay, let's have an example. So, example, kita para mas hapos mention dihan. So horizontal speed of a baseball is hit with a horizontal speed of 25 meters per second. What is its position and velocity after 2 seconds? Okay, take note, ang ginpamangkot sa aton is ano nang iya position kag ang iya nga velocity. That means di na siya nayon, ano iya nga velocity after 2 seconds kung ginhit siya naton with your initial velocity nga or speed nga 25 meters per second. Okay, so una-una, let us find the horizontal kag vertical displacement. So hapos lang man ang formula natin for horizontal vertical displacement. So we have, so V horizontal lang nga value sa imong initial. So horizontal niya lang nga value P is equal to 25 meter per second. So take note, pag hit ni mo sang ball, automatic that will be your horizontal nga value. So that will be 25 lang. Input lang diretso 25 meter per second times 2. Amo na din ang imo nga horizontal displacement. Next, for your vertical displacement. So that will be, so 1 half. So based on formula nga gidiscuss natin kagina 1 half g t squared na lang. So we have, kay wala man kita sang vertical component, dapat di ba v o y t plus 1 half gt squared. So since wala kita vertical component, so we have 1 half gt squared na lang. 1 half times negative 9.8 meter per second squared times 2. So we have negative 19.6. So we are considering sa ating gravity as negative gid kada term because it is pointing downward. So ano ang boot silingon sa negative 19.6 meters? That means halin sa imong initial point ara siya sa dalong. So this one, pag maglapaw siya sa imong initial point tanan na positive, pag manaog siya or below siya sa imong initial nga point, so a reference point naton, that will be negative. So the question is, what next nga question is what are the velocity components after 2 seconds. So the velocity components after 2 seconds. So bot silingon, ang ginapamangkot sa aton is the x and y components. Ang velocity, kung ang aton nga time is 2 seconds na. Okay, for the horizontal and vertical velocity after 2 seconds, so we'll have, so your VOX, so still the same lang man na. Take note, ang imong horizontal component wala ga change. So same lang Japon. Okay? So if we go back sa aton nga problem. Okay, so next, for your Vy, so we have to consider some y component. So we'll have VOY plus AT. So still the same. So Vy naton will be, so 0. Kita kay wala kita diri y component. So we have next plus G ang aton gamiton nga acceleration, which is hambak ko negative na lang. Then aton nga time, which is 2 seconds man lang Japon. So still the same sa aton nga nakuha kagina nga value. This time, kagina sa aton nga mga example, kag sa aton nga consideration, we consider nga horizontal component lang ang aton nga initial velocity. What if ang aton nga initial velocity is projected at a certain angle? But silingon, halin kita diri sa sininga point and then i-project siya. But silingon, naka-form kita sa complete projectile. So, ang natabo kagina, diri lang kita nag-start sa tunga-tunga. So, we have that half lang projectile motion. So, we have the complete nga projectile motion. So at the same time, the yellow ball is thrown vertically upward and the green ball rolls horizontally with no friction. So kagina ginantaw naton, we have duwa kagina, halin kita sa babaw, halin kita diri sa pinakataas kung ano ang matabo sa ila. This time, tatlo aton nga ball ang kinahanglan consider. Number 1, in a complete projectile motion, we have also the yellow ball thrown vertically upward. So vertically upward lang siya. And we have your green ball. So considering no friction kita, so madari-diretso siya sa horizontal motion. So, this one, gin-present ko ang tatlo ka type of balls para makita natin kung ano ang mga difference nila. So, sa ilang vertical kag horizontal motion. Considering nga wala taas ng iban nga mga reactions kag mga forces nga maka-affect sa ila. Okay? So, we have, at if ari na sa sininga point ang imo nga projected nga or ang may projectile, so ari naman sa sininga point ang imo vertical. Same man sa imo nga horizontal. So as we go on, so makita naton nga amo na ni siya, amo man Japon. So still the same, in the same position sa imo projectile, amo man ang vertical motion sa imo projected upward lang, ang imo nga projected ang imo nga horizontal lang ang motion. So take note, same lang gid Japon, wala, same lang ang ilang distance nga travel, same man lang ang ilang either horizontally or vertical nga motion. Take note, your pinakataas diri nga velocity will be the same. It will be constant. So both silingon, at this point kung ano niya ang ma-reach niya, still amo man ni Japon ang ma-reach niya. So same man. So we have to consider the same man Japon because we are in the sa air nga consideration. Both silingon aton acceleration will be considered as the force of gravity lang, which is negative 9.8 meter per second squared. Kay downward ang motion. Okay, so we have to calculate still with the displacements of general projection. So kabalo kita nga based sa aton nga calculation, still the same lang man na Japon. Components of displacement at time t are, so still the same. We have for your x, we have, take note, x lang di tanan gina-consider ta. VO still the same man, VI or VO still the same lang. VIT plus 1/2 AT squared. But we have to consider the x components only. For y component man, VIT plus 1/2 AT squared. So, okay, but take note, for projectiles, may ara kita kinanglan i-consider. Your AX is equal to 0. Wala kita acceleration horizontally. So, vertical lang ang may acceleration. AY, so AY natin will be equal to gravity. So, initial natin nga Y component will be equal to 0. Then initial naton nga x component will be equal to VO. Okay, kung ano lang ang value sa imo nga initial velocity. So, but siningon, ang aton nga displacement components of x and y for projectiles are, for x, or the horizontal naton nga components ng projection will be VOXT. So, amo lang naton formula. For y, still the same, amo man ni Japon, nagamit naman naton kagina. Okay, for the velocity calculation for general projection, so the components of velocity at time t are this one. So Vox plus AXT, Voy plus AYT. So we have the same nga formula. But ang kinalain niya lang, we have to consider kung ano siya nga component, either horizontal or vertical component. Okay? So take note lang sa mga kinanglan Japon itandaan, your acceleration, wala kita acceleration horizontally. Your vertical acceleration is due to gravity. Your initial na components ng mga velocity will be 0. So, but silingon, Vx natin will be Vox lang, which is constant. Vy natin will be initial or the vertical components ng initial velocity plus gt. So, we have to consider if we will be applying some projectile motion nga concept, kinahanglan natin mag-solve some problem. And here are the list enumeration of the process kung paano kita mag-solve sang projectile motion ng mga problems. So number 1, resolve initial velocity into components. So kabalo kita nga aton gina-consider will have a projection nga may specific siya nga angle. So we have to consider, for example, amo niya aton theta. So kabalo na kita kung paano naton kwaon ang aton nga vertical kag horizontal components based sa aton nga mga previous nga discussion videos. So we have your horizontal component, horizontal, subot sila nga adjacent siya, so we have cosine. VO cosine theta. Next, for your vertical component, so that will be your VO sine theta. VO dali is kung ano ang values ng mga initial nga velocity. So next, we have to find the components of the final position and velocity. So we have final position and velocity. Take note of the following formula. So ayun na, nagamit naman natin kagina, but just take note of the formulas. Next, the final position and velocity can be found from the components. Okay? So, if makita natin, we have your Vx and Vy. So, pwede na natin makuha ang imong velocity. So, we have to solve for your resultants ng imong final nga nakuha nga value. So, that will be still pareho sa aton yung ginhimo sa una nga naton nga klase. So, ano lang, Pythagorean theorem. So, r squared of x squared plus y squared. And for finding the direction or your theta, that will be equal to, so kung i-convert na di theta na lang, that will be arctan of y all over x. Okay? So, since nahambal naton, so amo ni may VO, kita kag VY, so still the same, so amo lang man na siya po nga process. So use correct signs. Remember that G is negative or positive depending on your initial choice. So for the consideration naton, basta gapanaog siya or ara siya sa ating consideration, that will be negative. Okay, so more example kay para mas maintindihan gid naton. A ball has an initial velocity of 160 feet per second at an angle of 30 degrees with the horizontal. Find its position and velocity after 2 seconds and after 4 seconds. Okay, so kabalo kita ang amo niya aton nga ang itsura sa aton nga representation. So we have, so initial naton nga velocity will be 160 feet per second. So amo ni 160 feet per second. So pwede naton siya i-split into its vertical kag horizontal component. Vertical component or your horizontal component na ito is unahon. Horizontal, so that is adjacent. So we have cosine 30. So 160 cosine 30 is 139. Okay, so ari siya. VOY naton will be 160 feet per second. So since opposite siya, so that will be sine 30 degrees is equal to 80 feet per second. So mayroon nakita sa ang aton nga horizontal ug vertical components sa aton initial velocity. So since Vx is constant, the horizontal displacement after 2 and 4 seconds, so kabalo na kita, hindi na ni mag-change. Amo na gid niya aton nga uh, horizontal nga components ng velocity. So pwede na naton i-solve ang aton nga horizontal displacement diretso. So maghambal to displacement, that will be velocity times time lang man. So that will be or the aton nga rate times time, so multiply to lang ni by the given nga time. So for your 2 kag 4 seconds. So we have 139 times 2. So at 2 second, ara siya sa 277 feet. And then for your 4 seconds, we have 554 feet. So amo lang na. Okay, so we know only the horizontal location after 2 and 4 seconds. We don't know whether it is on its way up or on its way down. So wala kita kabalo. Nabalaan lang natin ang horizontal location based against suma natin. Okay, so next we find the vertical components of the position after 2 seconds after 4 seconds. So tan-awon ta ang aton nga kung addiin na sila ano nang iyang vertical position. Okay, so take note, hindi natin pwede gamiton ang negative 9.8 meter per second kaya ang aton gina-consider diri is feet. So ang aton nga unit dapat should be in feet. So ang aton nga gravity will be negative 32 feet per second squared. So the vertical displacement as function of time. So we have VOY naton nga value na solve naton kagina will be 80 feet per second plus your 1/2 g t squared. So solve ta lang, plug in naton ang tanan nga mga given kagang na-solve naton. So we have VOY will be 80 feet per second times time naton. So kung ano na din nga time, so we have 2 kag 4 plus 1/2 your gravity nga negative 32 feet per second squared times t squared. So plug in lang natin ang mga values. For we have, kung i-simplify natin, that will be 80t minus 16t squared. Okay, so we have, so vertical position natin. So kung i-substitute natin ang 2 seconds, kay kinanglan natin i-solve 2 seconds to 4 seconds, so we have, that will be 96 feet. So silingon, 96 feet. Next, we have 80 times 4 minus 16 times 4 squared, that will be equal to 16 feet. So anong silingon sini? Silingon, they are all positive. So silingon at 2 seconds, ari siya dari 96. So silingon, positive siya, sa babaw siya. Siyempre kay amo ni nga initial nga or reference point. So next one, we have 16 feet. So ari na di siya. So nanaog na siya. 16 feet. Halin sa reference point natin. Okay, so each above sa aton nga origin, kaya aton nga answer is positive. Next, we find the horizontal and vertical components of your velocity after 2 and 4 seconds. So after 2 and 4 seconds, so we have VOX kag VOY, the horizontal kag vertical components. So we have 160 feet per second cosine 30, so that will be 139 feet per second. Your VOY will be 80 feet per second nga na-solve natin. So VX will be constant. So both silingon, VOX natin will be constant at all times. So amo lang gid niya nga value, hindi na gid niya change ang horizontal. For the vertical, it will be affected by your gravity. So we have to consider your VY at any time. So we have at any time t. So VOY, so kung i-solve natin, at 2 seconds, sa 2 seconds, ang imong VY is, okay, so 80, so substitutan ta lang sang 2, so that will be 16 feet per second. Next, 4 seconds, amo naman ni atong value. Negative 48 feet per second. Okay? So, that means, kakakita natin dire. So, 16 feet per second, sa 2 seconds, buot silingon, ari siya dire. Kapababaw. Next, for your 4 seconds, buot silingon, kapapanaog na siya. Okay? So, ari na. Based sa aton nga illustration, we have okay, at 2 seconds, ari na di siya. Your y component is positive, your x component is positive. For 4 seconds, aton nga x component, the same man Japon, wala siya nag-change. Your y component, nag-negative na. So the signs of Vy indicate whether motion is up or down at any time value t. Okay? So, sa 2 seconds, amo na natin yung mga values nga nakuha. 139 feet, so constant man na. Then, 16 feet per second. For 4 seconds, we have still the same nga values ang ating x component, but your y component is already negative 48 feet per second. Okay, so kaon natin ang the displacement r to theta is found from the x2 and y2 component nga displacements. Okay? Kaunta ang value sa aton nga r ang aton nga theta. R naton is equal to 277 feet squared plus 96 feet squared. Okay? Okay, so we have based kagina sa ating nga mga nakuha nga values, so that will be equal to kundi na sila na yun based sa ating nga calculation kagina. So R naton will be equal to 277 feet squared plus 96 feet squared. So kaunta lang aton nga R, so that will be equal to 293 feet na lang. For the value naman kung ano ang theta or ano na ang angle naton, so that will be 96 all over 277 feet. So, i-arctan lang na siya, makuha ang ating theta at 2 seconds, which is equal to 19.1 degrees. So, similarly, ang mo na Japon natin himuon for the values ang aton nga R sa 4 seconds naman. So, pila ni siya. Okay, so, pila ni ang R, pila ni ang ating nga theta. So, that will be equal to, so 554 plus 6 squared plus 64 squared. So, kaunta 558 feet. And then, we have 64 kag 54. So, kaunta lang arcta niya. So, we have 6.59 degrees. Basi ka confused ka mo kung di na halin nga mga values. Halin na siya sa una-una, tapos naging solve kagina. KD horizontal kag vertical component. So, we have here, ari nga mga values. Okay, so amo nga mga value ang atong gina-consider x kag y component. Okay? Amo na siya ang aton nga ginalantaw nga gina-solve. So, amo ni siya subong x and y components. Okay, basi na-confuse ko mo kung din dali. Okay, let us proceed. So, tapos lang na, since makuha na natin tanan-tanan. Susubong, pangitaon na natin ang velocity after 2 seconds. So, that will be, so, gamito natin ang aton nga, mga na-solve nga, x kag y component sa 2 seconds kag 4 seconds. So, butang talaman din Japon, that will be 140 feet per second. Same with your theta, same on Japan formula, that will be 6.56 degrees. So for 4 seconds, similarly, same lang Japan formula, plug in lang natin and we will come up with 146 feet per second and the theta will be 341.7. So we have this one. So this is it for now. Medyo lawig-lawig na. I will be making another video lang for another examples. So this is it for now. I do hope medyo maklaruhan ka mo and kabay pa nga studyhan tani. So, and don't hesitate to ask questions kung may mga hindi gid na intindihan. So this is it for now. Thank you. Stay safe. God bless.